So in terms of personality types, intelligences, um, and Myers-Briggs, in general, existing robotics curriculum is better for some, but not as inclusive as it could be. So, what are we doing in our classrooms right now as tech STEM teachers? It's usually some sort of robot competitive event. If we click on this video, it'll take you to a competitive event with robots, right? And so, common one is something like robot soccer, where you have to push balls into a goal, and you score points for a low goal, high goal. And there's good problem solving, there's good teamwork involved, um, but I find there's room for improvement. So if we raise the question, what are some challenges with common robotics projects or competitions, right? So one of the things I find or feedback I get from students is that it can seem a kind of abstract, like the robots don't move like the players or look like them, right? So this is robot soccer. Um, Another challenge I get is not everyone wants to compete, uh, and they're not that points driven, right? And so this can sometimes also challenge intra and intro personal development, right? They get too obsessed with winning and don't really learn kind of the deeper meanings of robotics design and things like that. Usually, these kinds of things are have more room for expression, have more room for aesthetic considerations or artistic considerations. These robots are kind of like cold metal, ultra practical, utilitarian robots, right? There's more opportunity to incorporate music and more opportunity to incorporate nature, right? If you know the companies that sponsor robotics programs, a lot of them are uh, big corporations that need industrial robots to manufacture things, or they're military research and development companies that are designing the next tank, the next plane, which is fine, but it may not cater to all personalities, such as the blues, who tend to be more empathetic. All right, and I found that generally a lot of existing curriculum is better for gold, green, and oranges. If you think about dominant brain theory throughout the robotics classroom, and probably by immediate affiliate, thinking you may think the robotics is really numerical, logical, science driven, analytical, accurate, but there is a creative aspect to it. So as we teach different parts of robot design, the coding part, right, where you have to create if then statements to program the robot, is really good for someone in a group to do the with the good left brain, right, doing that numerical sequential type of thing. When it comes to following an instruction, right, a diagram, a exploded isometric view of a robot part, different people in different groups are going to use different things, right? So if you get someone that's more right brain dominant or has better spatial intelligence, they're going to look at the shapes and the colors to put this part together. All right. Whereas if you get someone who's numerical, accurate, analytical, they're going to use um, these abbreviations, right? These are all designations. This is part R16. This is part BF. This is part designation SS dot SS. So it's good that has both, but I guess want to consider making sure that they get both, and that we think about these two things on a broad scale. So how can we better design robotics projects or learning units to reach all types of personalities, kind of move away from the robot sports? How can we incorporate more aesthetics, move beyond points-based competition, and add a project unit idea that allows a little more consideration for expression, art, music, naturalistic intelligence? Include the blues in addition to the other three colors there. Have you do an activity And let's create a mind map, right? It's sort of a graphical organizer thing. And I want you to sit down with a group, if we were doing this live, and use the collection of images or collages to the right to mind map ideas for a design brief that may reach many personality types, colors, and multiple intelligences as possible. So, what do we have? We have toy, the clapping monkey, I have a jack in the box, right? This is a robot cleaning sand off the beach. This is a map. I want you to start thinking about the way robots are coming into society. So here in New Jersey, in Leonia, they just built a field station dinosaur park, which has all animatronic, mechanically moving robots, right? And Disney is doing more of this as well. If you click on this video, some examples in my own classroom of how I do this to reach maybe the naturalists or people who are more environmentally, socially driven is I make recycling robots. Our recycling today is commingled, meaning that we don't have separate containers anymore. So a one large um, container gets taken to Newark and then it's separated on site there. And so to kind of replicate that process, I have them make a machine that can sort four different materials, or as a simpler task, sort four different coins. So this one is actually a coin one, and each coin represents something like a plastic bottle, aluminum can, a cardboard piece, and something else like newspaper. So they put the bulk materials in here. This spins, right, and it goes down the slide into four separate containers, right. And if you were to click on this video, it'll show you how that happens in the real world in Newark's waste management facility. Another one I do, and this is a bit contradictory in class, it's trying to move beyond the military inspired, but you could alter this as an all-terrain bot. But this one kind of caters to people who like to be outside and do this project in June in our courtyard, right? And so they have to design a robot that can autonomously navigate through an urban area, climb a mountain, and then throw a marble. Right. And this is the next unit that I'm developing that I hope we can actually do together with PD participants, because it's a really challenging type of robot to make, and we would need all different types of personality types to be able to do this. It's an animatronics unit, right? So this is from Disney's YouTube channel. So I think in the old days, when they were designing animations before CGI, they did have to do some kind of mechanical modeling, right? Or making mechanical prototypes. There's a lot of learning here with levers, linkages, and so can we make a robot that is programmed to dance to a song? Can we make a robot that is kind of choreographed? Let's discuss together as technology teachers. So, conclusions from today's slides in PD. Despite being an elective subject, we will have multiple intelligences in the classroom. Different personality type behaviors can be seen in different parts of design work. Having a mix of competition and artistic, socially driven projects can naturally promote more inclusion. And above all, mix it up, keep it fun.